All right, here we go. 3 practice problems, conversion. These are going to be conversion problems, and this time we're going to do area and volume conversions. So please copy this equation or this problem into your notebook. We're going to convert 4.5 millimeters squared to meters squared. You start the same way by getting your conversion relationship. So 1 millimeter is equal to, if I look at the red handout, 10 to the minus 3 meters. Okay? And now we will rewrite the number that we are trying to convert with the unit. So that's 4.5 millimeters squared. Still do the same thing. You multiply by some fraction. Okay? Into the fraction, you know you're going to put these relationships. I want to cancel millimeter squared ultimately, so I'll put the 1 millimeter in the denominator. We want to go into meter squared, 10 to the negative 3 meters in the top. And now, because we're converting square units, the second dimension, we're going to square the whole thing. So we square our conversion fraction. I'm going to square the 10 to the negative 3. I'm going to square the meters, square the 1, square the millimeters squared. This becomes 4.5 millimeters squared times 10 to the negative 3 squared is 10 to the minus 6 meters squared. All over 1 squared is just 1 millimeter squared. Our millimeter squared cancels. We're left in square meter units, and our final answer is 4.5 times 10 to the minus 6 meters squared. Okay, next problem. Practice 2. Convert 2.2 cubic kilometers, kilometers cubed, to millimeters cubed. Go ahead and copy this question. And we'll follow the relationship from before, or we'll follow the same steps as we do before. We are converting kilometers into millimeters. So 1 kilometer is 10 to the third meters. And 1 millimeter is 10 to the minus 3 meters. Now that we have these two relationships, we can rewrite our problem. 2.2, or the number we're converting, 2.2 cubic kilometers. Remember, if we have 2 prefixes, we need 2 conversion fractions. Okay, so we're going to multiply by a fraction here and by another fraction, and we fill these fractions with these relationships. So we want to go out of kilometers and into meters, or out of cubic kilometers and into meters. So I'll write 10 to the third meters up top. And then eventually we'll go out of the meters and into the millimeters. So I'll write the 10 to the negative 3 meters below and the 1 millimeter up top. Okay. Now we have to bring these fractions up into the third dimension. So we cube them because we're converting cubic units. You're going to cube the 10 cubed. You're going to cube the meters. You cube the 1, which is just 1. You cube the kilometers. Here, same thing. You cube the 1. You cube the millimeters. You cube the 10 to the negative 3 in the denominator, and you cube the meters. Doing this, rewriting 2.2 cubic kilometers times 10 to the 9, because 10 cubed, you multiply those exponents, 10 to the 9 cubic meters, divided by 1 cubic kilometer, times 1 to the third is just 1 millimeters cubed divided by 10 to the negative 9 meters cubed. Let's see what cancels. Yes, we are in the target unit at the end. So this will be 2.2 times 10 to the 9 divided by 10 to the negative 9 millimeters cubed. Remember what to do, like bases, and you're dividing what you do with those exponents. In your final answer, it'll be 2.2 times 10 to the 18 millimeters cubed, a really big number when we're down in the millimeter cube scale. Next and final practice problem, here we go. We're converting density units now. We're going to convert grams per cubic centimeters into kilogram per cubic meter. Like we did in class, we'll go numerators first, we'll convert this first, and then we'll convert the denominators. So for our numerator conversion, to go from a gram to a kilogram, well, a kilogram stands for a certain number of grams. So 1 kilogram is 10 to the 3 grams. And I know these are cubic centimeters to meters, but a centimeter is 10 to the minus 2 meters. Okay? So this is our conversion for the numerator. So now I'm going to rewrite the 1.5 grams per centimeter cubed, and I'm just going to change the grams or convert the grams to kilograms with following this relationship. The 1 kilogram is 10 to the third grams. So I multiply by this fraction. We want to cancel the 10 to the third grams, and we multiply by a kilogram. So 1 kg on top, 10 to the third grams on the bottom. This is equal to 1.5 times 1, but I'm just going to leave off the times 1 kilograms divided by 10 to the third centimeters cubed. Notice how I'm multiplying on the bottom here across centimeters cubed times 10 to the third, but I put the number, the 10 to the third, in front of the unit. You want to put your number in front of the unit, always. So now I can simplify 1.5 divided by 10 to the third following our power rules. That's going to be 1.5 times 10 to the negative 3 kilograms per cubic centimeter. Next step, we are going to convert the cubic centimeters into cubic meters. So again, I will rewrite my 1.5 times 10 to the minus 3. This is kilograms per centimeter cubed. I'm going to multiply by a fraction. This fraction needs to cancel the centimeters and put us into meters on the bottom. So to cancel the centimeters, I have to put them diagonally. And this is all together, the 10 to the minus 2 meters below. And for this, we of course need to cube, because we're not canceling out the centimeters, we're actually canceling out cubic centimeters. So this will be 1.5 times 10 to the minus 3 kilograms per centimeter cubed times 1 centimeter cubed. I'm distributing the cube now, just like we did in the other problem. 1.5 centimeters cubed over 10 to the negative 2 cubed, that's 10 to the minus 6 meters cubed. Making sure things are canceling, my centimeters cubed cancels, that's good. So now I'm going to stack my tens. 1.5 times 10 to the minus 3 divided by 10 to the minus 6 times, and this is a kilogram times kilogram over meter cubed. Going to simplify this right here. 10 to the negative 3 divided by 10 to the minus 6. You subtract those exponents. So your final answer for this will be 1.5 times 10 third kilogram per cubic meter. And there we have it, some little extra practice for us. Thank you for watching this video and continue to study.